Assalamualaikum to Sir Nazri. As for today, we are going to present Coulomb's Law, which is Experiment 1 in Physics 150. This group are consists with me, which is Athira binti Anang.
My name is Shalina binti Muhammad YUSNI.
And my name is ATIKAH binti ZULKEPEli.
My name is NURUL NAJWA binti KHIRUDIN.
Without delaying the time, let's move to the first subtopic, which is objective. Next. As we can see, this experiment have three objectives. The first one is to satisfy Coulomb's law experimentally. Coulomb's law is defined as the electric force between two charges is proportional to the product of the charges and inversely proportional to the distance between them. So through this experiment, it is to check whether it complies with the law or not. For the second objective is to study the parameters that affect the electric force. An example of parameters that affect the electric force is magnitude. For the last objective is to find experimentally the electric constant K by using the formula given. So the formula to find electric constant is Fe equal to K multiply with Q1 Q2 over R squared. For the next subtopic is apparatus and materials that we have been used to complete this experiment. Next. The first apparatus and materials is pen, second calculator, virtual ruler, virtual metal block, paper, and graph paper. So next I will pass it to Najwa.
Thank you, Athira. So my turn is about methodology for this lab report. This lab report have two parts, which is part 1 and part 2. The first step for part 1 is the link were provided and we need to click the link. And the charge Q1 and Q2 was fixed. After that, their values will be written in table 1. Next, the distance between the two charges was changed as shown in table 1. Next, the force value was recorded for each distance. Lastly, the table 1, by finding R2 and 1 over R2 was filled. For the part 2, there are 3 steps. The first step is the same as part 1. We need to click the link provided and the charge Q1 and distance R was fixed. And their values in the table 1 were written. Next, Q1 was controlled and fixed at 5 microcoulomb and the distance between the two objects at 6 cm was fixed, recorded in table 2. Lastly, the charge of object 2 was shown in table 2 was changed, and for each Q2, the electric force between the two objects in table 2 was recorded. So next presenter.
Thank you, Najwa. In the next slide is about presentation of data, part 1. As we can see, in the table we have two manual, which is Q1 and Q2. The value of Q1 and Q2 is constant, which is 2 column for Q1 and 4 column for Q2. Besides, under Q1, we have two sub-row, which is R in cm and also R squared in cm. For R, the value is constant, which is 10 until 3. While for the value of R squared, it is from the experiment that we do. So that's why the value we get is not arranged. On the other hand, under Q2, it also have two sub-row, which is 1 over R squared in 1 over M squared and Fe in N. Value for both two sub-row also we get from the experiments that we carried out. Based on the table under 1 over R2 and also Fe, the value shown is increased. That's all from me. I will pass this presentation for the next presenter.
Thank you, Athira. So the next slide is presentation of data part 2. So for part 2, the constant is charge Q1, which is 5 microcoulomb, and the distance R, which is 6 centimeter. And the what to change is the charge Q2 microcoulomb. We start from 3, and the last charge was 10 microcoulomb, and beside the columns is the observed or the result of the force Newton, which is we get from 37.448, and the largest force is 124.827 for a Newton force. Next.
Okay, next we go through the analysis of data for part 1 in this experiment. First, use the Excel software and plot a graph relate FE and R and comment on the graph. For the second question, we are asked to use Excel and plot one more graph relate FE and 1 per R squared and use the graph to find the electric constant K. And then for the third question, we are asked to calculate the percentage error in K, as the K known is 9.0 multiplied 10 to the power of 9 nanometer squared per coulomb squared. Okay, next. Okay, in this slide, we can see the graph force Fe versus distance R, and based on the graph, the electric force Fe is inversely proportional with distance R. The graph shows that as the distance R increase, the electric force Fe will decrease. Okay, next. In this slide, the graph force Fe versus 1 per R squared was plotted, and based on the graph, the electric force Fe is directly proportional with distance 1 per R squared. The graph shows that as the distance 1 per R squared increase, the electric force Fe will also increase. Next, in the second question, we are also asked to find the electric constant. We use the formula Fe, which is electric force, equal to K, which is electric constant, multiplied with Q1, Q2 per R squared. Q1 and Q2 here is the charge of each object, which is Q1 for object 1 and Q2 for object 2. And R here is the distance. And the electric constant that our group get is 8.99 multiplied 10 to the power of 9 nanometer squared per coulomb squared. Okay, next. For the third question, we are asked to find the percentage error in K. We use the formula in modulus E minus A per A multiplied with 100%. E here is the experimental value that we get from the calculation earlier, and then A here is the theoretical value or the value known, which is 9.0 multiplied 10 to the power of 9. And the percentage error that our group get in this experiment is 0.1%. Again, I pass to the next presenter.
Thank you, Ayu. So for the next slides is analysis of data part 2. So the first one, the first one is use Excel software and plot a graph relates Fe and Q2, and then comments on the graph. And the last one is use the graph to find the electric constant K. Next. Here is the graph of force Fe versus charge Q2. So based on the graph, it shows that the force is directly proportional with charge Q2. When the force increases, the charge Q2 will also increase. Next. So here is for the second questions, which is find the find the electric constant K. So from the formula, it's same just the previous formula that you used, which is Fe, which is electric force, equal to K multiplied by Q1 Q2 over R squared. So so we compare with the general equation, y equal to mx plus c. So the m is equal to k multiplied by q1 over r squared. So we get that the electric constant k 8.98 multiply by 10 the power of negative 3 nanometer squared over Coulomb squared. Next, the last one is percentage error. So same goes to the next previous slide that you present. We use the same formula percentage error, and the percentage error that we get is 1%. Thank you. I will continue with the next presenter.
Thank you, Ain. So for me, I will discuss about the discussion for this lab report. This lab report is about the Coulomb's law. Coulomb's law is about the magnitude of an electric force that a particle exerts on another is directly proportional to the product of their charge, and it is inversely proportional to the square of the distance between them. For this experiment, we have three graphs that were plotted. Firstly, the graph of Fe and R. The relationship of this graph is inversely proportional. It shows that the higher the distance, the smaller the force. Next, graph of Fe and 1 over R squared, which has the relationship of directly proportional. For this graph, it shows that the higher the distance, the higher the force. The last graph is about the graph of Fe and charge Q2. It shows a directly proportional relationship. The higher the Q2, the higher the force exerts. These graphs were plotted according to the data in table 1 and table 2. The K predict, which is theoretical value, is 9 times 10 to the power of 9 nanometer square over square. But the results achieved K for part 1 is 8.99 times 10 to the power of 9 nanometer square over Coulomb square. So we know that there is some slight error occur during the experiment. Error was for 0.1% and were calculated using the formula E minus 1 over E minus A over A 10 times 100%. After that, K received for part 2 is 8.98 times 10 to the power of negative 3, and the error percentage is 1%. Errors that may occur is from human error, parallax error, and some random errors. So to improve the error, we can make sure the eye is perpendicular to measurement reading, such as ruler. Lastly, suggestion that can be made for the experiment is maybe making this experiment in real life or reality to avoid the data we take is inaccurately, and we can understand this topic more deeply. So next presenter.
Okay, thanks to Najwa. In conclusion, this vector experiment was done successfully, and the hypothesis is accepted, which is the first hypothesis: the farther the distance, the smaller the value of force, and the second one, the smaller the charges, the smaller the value of force. From the observation of this experiment and based on the data that has been recorded in Table 1 and 2, the magnitude of electrostatic force is related with the charge and the distance between the two objects. The electric constant K has been calculated and recorded experimentally, which are K equal to 8.99 multiplied 10 to the power of 9 nanometers squared per coulomb squared for part 1, and K equal to 8.98 multiplied 10 to the power of negative 3 nanometers squared per coulomb squared for part 2. This is the reference that our group used. And then that's all from us. Thank you.
Thank you.
Thank
Thank
you.
you.